Hello, can everyone hear me? All right, perfect. So welcome to Python Part 2. This is a sequel to the Part 1 of Introduction to Python that was run by one of the BITS members here, Shriven. Shriven is going to be monitoring the chat just in case you guys have any questions while I'm coding. And you guys could just drop it in the chat and he can either answer them for you or he can let me know at the end of the workshop. And I'll try my best to answer those questions. So yeah, a quick introduction about me. My name is Thad Teo. I'm a rising junior, class of 2022. I'm majoring in comp science, statistics, mathematics. I currently work as a data analyst at Tishfield Labs, which is a research facility right on Bush campus. It's that really pretty one with all the glass doors. So if you're ever around there, that's where I'm at. I'm also the current BITS webmaster, developing and maintaining the BITS website. And some cool stuff about me, I love basketball, video games, and coding. So real quick, I'm just gonna give the floor to Shriven. If you could speak up and introduce yourself.
All right, hi everyone. I know most of you guys do recognize me from the part one workshop of Python series, but just quickly for those who are newly joining today, yeah, I'm an incoming junior, double majoring in finance and bait with a double minor in statistics and health admin, and I'll be just moderating over the chat room for today. Try to answer most of the questions possible. And I currently serve as a tech development chair at BITS. So yeah, if you guys have any questions on the club or anything, feel free to drop it down on the chat room, and I'll try my best to answer all your questions. All right.
All right, thank you, Shriven. So really quick, we're just gonna go over the brief overview of Python. So first I wanna go over a recap on part one. Shriven did an excellent job talking about things that are pretty elementary in Python. Some of the basics such as syntax, data types, such as strings, ints, floats, data structures such as lists, dictionaries, tuples, and some operators like adding, subtracting, modular, and as well as typecasting, which can go from one data type to another, as well as some other stuff. But those are kind of the key highlights that we're going to be going over again for this workshop. So if everything I said just went over your head because you missed last week's part one workshop or just because you totally forgot about it, don't worry, because when we get to it, I'll be going over some of those things as we go. So on the agenda for right now is going to be packages as well as virtual environments and pip installing, as well as absolute imports. Then we're going to be going over to command line arguments as well as inputs. Then we're going to touch base on functions and what they do in Python, as well as what you can do with them. And last but not least, object-oriented programming, which is one of the most important concepts that you're going to learn, not just with Python, but with coding in general. And so the reason why all of this is important is because this is kind of building the foundation to creating not only small, scrappy projects, but huge full stack applications that you can use at work for like huge, S&P 500 companies. These are things that they do on their day-to-day basis, and they constantly are using these fundamentals. So it's really important to kind of have a grasp on that. So quick disclaimer, I know last Python workshop used Jupyter Notebook, but for the contents of this workshop, it'll be a lot easier to code on a text editor. So I'm gonna be using VS Code just because it's kind of my favorite one, but honestly, you could follow along with Notepad if you wanted to, which would be really painful, but I mean, I know some people that do. So real quick, let's just get right into it. The first thing we're gonna be talking about is packages, pip, and virtual environments. So what a package is essentially a piece of code that someone wrote and wanted to share with everybody else. So they let people essentially use it. And that's really all there is to it. The reason why these are important is because you never want to reinvent the wheel. So if somebody had a package that allowed you to add two numbers together and you didn't want to code that all by yourself, well, instead what you could do is just use that person's package and bam, you don't even have to code anymore. You can just use their code. So the way that you can install this is by using something called pip. Pip is the package manager for Python, and it's used for installing these packages. And so you're able to install as many packages as you want using pip. without having to really worry about like, oh, which version is it, or like, where am I getting this code from? All you need is the pip to be installed as well as the name of the package. Virtual environments. These are containers of code and packages that also have their own version of Python included. So essentially, if you need to conceptualize this, there's this graphic right on the right-hand side of the slide. So as you can see, there are 3 different virtual environments. There's 1, 2, and 3. And each of them have 3 different versions of this package called Ansible. So this one has the latest package version. This one has 2.0.0.1, and this has 2.4.1.0. So virtual environments allow you to install packages at different versions, so that if you had 2 different projects which used Ansible, but one was a dependency that had like a later version than the other one, then you wouldn't have to have them coincide. So I'm going to show you an example because it's kind of hard to understand why you need this in the first place. So I'm just going to pull up my command line right here. So if I type pip list, this is going to give me a list of all the packages that are installed on my Python machine. So as you can see, there is a lot. You know, everything from like Asteroid to Wrapped, as you can see here, there's a lot of packages. And all of these packages have different versions. So there's 3.1.5, like 0.2.0. But what if I wrote a piece of code that only worked on a certain version, and as soon as you upgraded that version, the code broke? Well, that's the reason why you use virtual environments. So what I can do is I can create my own virtual environment by typing python/m venv, which stands for virtual environment, and the name of the environment. So I'm just going to call this environment bits. So after some time, it's going to be creating my virtual environment. Inside of this virtual environment will be a package or a script, and I can show you that right now. So I'm going to change my directory to env bits. CD just means change directory. It's kind of like a universal terminal thing, which allows you to just go to that folder. So if I list out the contents of this folder, you can see that there's something called scripts right here. So I'm going to go to scripts, and I'm going to show you the directory again. And if you see here, there are 2 things, pip.exe and python.exe. These are the things that you need in order to run Python, essentially. And there's one last thing called activate, which activates this virtual environment on your computer. So if I type activate, I now have a virtual environment running by, and I could tell that by like this indication right here. It's the name of the virtual environment inside parentheses. So if I wanted to install something like pandas, for example, pandas is another package that I know of. You could just type in pip install pandas. So as of right now, it says that requirement already satisfied. That's because I ran the code already. But if I type pip list, you see that there are essentially just like, what is that, 6, 7 different packages. And the reason why there's only 7, as opposed to if I go to like my basic Python and type pip list, there were like, you know, like probably 50. The reason why is because when you create a new virtual environment, there are going to be just the bare minimum requirements. There's only going to be 2 packages essentially, which are setup tools right here and pip. So when I ran pip install pandas, it installed pandas as well as some dependencies like numpy, python date-util. But this is really what you want when you're creating a new Python project, is you want to have like a minimalistic ideology where you only want to install what you absolutely need. So if I were to create a Python project, I want to only install stuff on my virtual environment, not my actual base Python environment. So again, the reason why this is very important is because when you're working with a company, let's say you're working with Google, I could bet you $1,000 that they have over 1 million lines of code in Python and over 100 developers that are just coding in Python. And when you have 100 different people that are working in Python and they all have their own dependencies, their own packages that they have to install, it becomes a mess to determine which project requires what packages and which project requires what version of each package. So virtual environments kind of help to containerize that. So we're gonna move away from all of this stuff and just like let it like, you know, ferment in your mind a little bit. It's kind of like a weird topic, but I had to go over it because it's really, really important. But for now, I'm just gonna go over actually coding stuff now. So the first thing we're gonna go over is command line arguments. These command line arguments are essentially things that you pass into a program that you can have access to inside of your program. So the way that you do that is if you look right down here, this green text, you can type Python and then the name of the Python file that you want to run. So just these two keywords, which is Python and your file name, is what you need in order to run a script. So anything after that, separated by spaces, are going to be your command line arguments. And the way that you access this is through a list. So if you don't remember what a list is, I'm going to pull up my IDE right now. So if you don't remember what a list is, essentially what it is a data structure that allows you to put in as many things as you want. It could be strings, it could be numbers, it could be decimals, whatever you want. So in order to create a list, you just give it a variable name, which is li, and set it equal to some empty brackets. And now if I wanted to add some stuff to it, like some numbers, instead of empty brackets, I could do 1, 2, 3, 4, 5. And if I wanted to access a certain element and give that a variable name, so let's just say first element, I could access that by going li and then open close brackets and going to spot 0. So the reason why spot 0 is because indexes start at the 0th number, I guess. That's just kind of how programming is. It always starts at 0 and works their way up. So if you wanted the 5th element, you would have to go 0, 1, 2, 3, 4. So if you wanted the 5th element, that would be 4. So essentially, that's how lists work. And in order to access the arguments, if you want to access the arguments for command lines, all you have to do is access a list called argv. So this is what I'm talking about. This right here is a list that contains all of your arguments. In order to access it, though, you need to install a package, and this package is called sys. So in order to import that, you just type import sys, and inside of this package, like I said, contains argv. So in order to access argv, you just use sys.argv. So really quick, I'm just going to print out these contents and see what happens. So Python main.py. Okay, so you see here that it prints out a list that contains one argument, which is called main.py. So just remember, the first element is always going to be the name of the actual file. So that's really important to note because sometimes it messes me up when I'm trying to access other command line arguments. But what happens if I type Python main.py and then arg1, arg2? Well, as you expect, arg1 is going to be in the 2nd index and arg2 is going to be on the 3rd index. So really quick, knowing this, I want to make a little script that takes in two numbers and adds them together. All right, so I'm going to do just that. So I have to first import sys, and I have to grab the first element, which is going to be my number. So sys.argv1. So remember, I'm doing 1 because that is going to be the first actual input that I give it besides the file name. And then I'm going to do sys.argv2. And I'm going to set these equal to a variable, so just x and y. And I'm going to print out the sum of both of these numbers. And so I'm going to run Python add command line .py, and I'm going to do 10 and 12. So before I hit enter, does anybody want to take a jab as to what this would print out? Just go ahead and type in the chat below. Anyone want to guess? So I am taking 10 and 12 and I'm printing it out when I do x plus y. So someone gets 22, which obviously is what you'd expect. But the weird thing about using these argument variables is that when I hit enter, it's not going to print 22. It is going to print 10, 12. So obviously adding 10 plus 12 doesn't give 10, 12. You know, I wish it did. That'd be super cool. But the unfortunate thing is that when you grab these arguments right here, so sys.argv1 and sys.argv2, these are strings. So when I put in 10 and 12, this outputs the quote literal 10, and this is the quote literal 12. So there's something in Python called casting. And I see someone said, do we have to use the int function? Yes, we do. That is what's called typecasting. If you don't remember from last workshop, typecasting essentially allows you to change a data type from one thing to another. So if I surround sys.argv1 with the integer function, as well as sys.argv2, it is no longer a string. It is now casted into an integer. So if I run this again, it'll now print 22. So just keep that in mind. These arguments that you're fetching from the sys.argv list is always going to be strings. So, handle that accordingly by casting or by doing some error checks and stuff like that. Okay. So the next thing that we're going to be using is the input function, which is built in. Essentially, it just prompts the user and it just makes it a little bit more user-friendly. So if you look at the top right here, I first do my prompt. I say like enter your name, and then I use the input function. And after that, I print hello plus whatever the user input. So you can see the result here. It says enter your name, Thad, and then hello Thad. So let's implement that. Use input function. Okay. So like I said, the input function is built in, so you could use that whenever you want, but always remember that there's going to be two steps to using the input function, all right? There's going to be, first, you have to prompt the user. You want to prompt the user to tell them what to actually put into the command line. Two, you're going to grab the user data. Okay, so, pretty simple enough. So let's have an input that or a prompt that says give me your name, and then x is equal to input, and then I just print your name plus x. So it tells me, give me your name, so I'm going to give it my name, and it just says that. Cool. All right, so with this in mind now, let's make a another script that adds two numbers together using the input function. So again, you'll first want to prompt the user. So print, give me a number. And I'm going to set this equal to x, just some random number. And give me another number. And I'll set that equal to y. And then I'm going to print x plus y. So again, I want you guys to take a jab at it. What do you guys think this will print out if I do 10 and 12? So add input.py 10, 12. Just put your guesses in the chat. Yeah, there you go. All right, more people are catching on. So if I do this, or 10, 12, it does 10, 12. I did not mean to do this here. I forgot that we were using input function, but whatever. So yeah, it prints out 10, 12. And the reason for that, again, is because we didn't cast it. So you can cast it by doing this around the input function, right? Or you can do it afterwards. So x is equal to int x, y is equal to int y, right? So then 10, 12, it gives 22. Perfect. So now we have two different ways of grabbing user input, one from the command line and one from the input. So let's move on. Now we're going to go on to functions. So we're going to take a little bit of time to explain what functions are, but essentially they're a chunk of code that you can call repeatedly throughout your program. So this really just allows you to not have to repeat yourself and be a Control-C, Control-V warrior. They allow you to kind of like repeat yourself during one iteration and not have to ever like type in all of that stuff again. So this takes in parameters in the parameter header, or sorry, the function header. So if you look at this little thing right here, this picture, number is a parameter, and this line right here is a function header. So anything below it is going to be a part of that function. And the way that Python tells if it's no longer a part of your function is if there's no more tabs. So right here, return number times 2 is tabbed over, and x equals 3, y equals all that stuff. This is no longer tabbed. So this part right here, these 4 lines are not part of this function. So let's try that out real quick. I'm going to go functions. So the way that you define a function is by using the def keyword and then the function name. So let's just call this function 1. And after the function name, you have to have open and close parentheses, and inside of here, any parameters that you want to name. So I don't want any parameters, so I'm just going to leave it empty. And then afterwards is a colon and then a tab. So remember, this is tab separated. So this is in function. This is also in function. But as soon as you remove the tab, this isn't in a function. Okay, so this is kind of similar to if statements if you remember for part 1, or if you just have like a little bit of background with Python. So if you have an if statement inside of a function, so if blah, 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 if you have an if statement, this has to also be tab separated. So there's going to be 2 tabs. All right. So if I had another if statement, there'd be 3 tabs. It's like cascading stuff, and it makes it a lot more visually appealing. So that's kind of cool. All right, so let's just make a function really quick that prints out hello world. So if I were to run this right now, just give me a second. All right, so if I were to run this right now, you see that nothing is printed out. And obviously it should. I mean, I'm defining a function right here which prints hello world. But the thing about functions is they never run unless you invoke them. And invoke is just a fancy word for call them. So I'm going to invoke function 1 really quick by just, after the function, you see there's no tabs here, just calling function 1. So after that, it prints out hello world. All right, cool. So now we can go on to creating cooler functions. So I'm going to create a function 2, which takes in a name. Oops. And just prints out hello plus name. So this right here is called concatenation. It's combining 2 strings together. So you can do that by doing plus and then a name, or you could do something called formatted strings. So what formatted strings are is instead of doing, string plus string, you can do F and then your single quotes. And then you could run a formatted string. And what that is essentially is you have your regular text, but as soon as you want to put the value of a variable inside of your string, you can have open and close curly braces, and in between those, you could have the name of your variable. So let's run that again by invoking function 2 and running it. Oh, oops. Thad, there you go. So there you go, it runs hello Thad. So let's make a function really quick that adds 2 numbers together, because that's something that I really want to have done, is adding 2 numbers together. So really quick, def add numbers x, y. So here I want to actually give you a value. And with functions, that's oftentimes what you want, is you want to give somebody a value. You want to give a variable a value. You want to like give another function a value. So how do I do that? Well, if I were to print x plus y, and don't worry, this isn't another casting trick that I'm going to pull on you. I'm actually going to give it like, you know, numbers. So if I run x, y, oops, I keep doing that, 4, 6, functions.py, it prints out 10. Okay, that's cool. So what if I wanted that value and I wanted to use it elsewhere, right? So let's say that x is equal to add numbers 4 and 6, and then y is equal to add numbers like x plus 10. So if x is equal to 10 after adding 4 and 6 together, and y is going to be x plus 10, then y should be equal to 20. But if I were to run it, if I were to run it, it doesn't say, oh, sorry, print, print y, there you go. If I were to run it, it says unsupported operand types, so non-type. This essentially means that there is no value here. And it is telling me that at x. So if I hover over it, it says assigning result of a function call where the function has no return. So if I wanted to give a value to x, I can't just print this because all it does is it makes the console say the number 10. Instead, I have to return that number. So x plus y. So I'm going to clear this really quick and I'm going to run it again. And now you'll see that y is now equal to 20. So that's perfect. That's what we want. So now let's go over like using functions inside of other functions. Let's create a function that multiplies numbers. X, y, and all right. So what I'm going to do is essentially, instead of doing multiplication, I could easily do that by doing x times y. But instead of doing that, I'm going to like showcase how you can use functions inside of other functions. So if you do not remember from last workshop, this is how you run a for loop. This for I in range y essentially means run whatever is going to be here y times. So what I'm going to do is I'm just going to set ret equal to add numbers ret and x. So if you don't know what ret means, that just means return. That's something that I like to always call my variables, which I'm going to end up returning. So then I'm just going to return ret. So if you don't understand the math right here, it's really just like setting ret equal to repeated adding. So like 0 plus x is going to be x, and then it's going to be x plus x, which is 2x, and it's going to do that y times. So it's going to end up repeating until it hits, you know, y times x. So I'm going to run multiply numbers x 4 times 6, and I'm going to set that equal to y, and I'm just going to print that really quick. So obviously it works. 4 times 6 is 24. And this is the reason why returning inside of a function is so important, is because you're able to not only grab a value from a function, but also it persists throughout your program. So you're able to store it into a variable and have that variable throughout the majority of your program, or, you know, until like a function. But yeah, that's essentially what I just wanted you to have like a really key takeaway, is being able to use functions inside of functions. All right, so the last thing that I'm going to talk about with functions is positional versus optional arguments, okay? So the entire time we've been just putting x and y, and inside of main, we had like name, or we had no arguments. But something that's really important are optional arguments. This is something that sounds exactly like it is. It's optional. So in order to do that, let's just create a function header, optional. Okay. So if I wanted to have an optional argument, let's say I wanted my argument that's called C to be optional, okay? And A and B are not optional, they're positional. If I wanted C to be optional, I could just give it a value in the first place. So let's say that I always wanted C to have the value 4. Well, all I could do is just set it equal to 4. And now if I print C and then run, and then run optional, giving it only A and B, so 1 and 2, keep in mind that there's a third argument, but it's not throwing an error because this is an optional argument. If I run that, it prints out that C is equal to 4. But what if I don't want it to be 4? What if I want it to be like nothing? Well, I could just use the keyword none. And if I print C again, there you go, it's none. So what if I wanted C to equal 4 and I wanted D to equal 5, right? But I don't want to change C. I only want to change D. So again, I'm going to give A and B a value, so let's just give it 1 and 2. But again, I don't want to change C, but I want to change D. So if I were to do like C is equal to 0 and like D is equal to 5, or sorry, like 9, I wanted to change D to 9, then like that would work, except C is still equal to 0, which is what I set it at. And if I just like ignore that and I just do like 1, 2, 9, then I mean, like, where does that go? You know what I mean? Like 1, 2, and 9, like where does this 9 go? Oops. Like 9 goes to the C. But I want to change D. So the way that you can make things optional is you have to give your positional arguments a value, so 1 and 2, and then give your optional arguments a value. And the way that you do that is by setting D equal to like 12 or something. So if I were to print again, you can see that C has not changed. It is still 4. So this is kind of like making Python as kind of as dynamic and as versatile as possible, because you can have arguments that are absolutely required, but you can also have arguments that you don't need. So D, I don't have to change at all, or sorry, C, I don't have to change at all, and I don't have to change D either. But what if I wanted to? Well, I could change it right here by doing D is equal to 12. And it doesn't throw any errors, and D will successfully change. Or I could show you that D will successfully change. There you go. D is equal to 12, and C is still equal to 4. So that's kind of like the power of Python and being able to have optional arguments. A lot of programming languages such as like C++ and Java, they don't have this opportunity to do that because, well, they just aren't as good of a programming language as Python. Obviously, I'm a little bit biased, but all right, let's move on. So with functions now, we're going to be going into object-oriented programming. So this is a concept that is really, really important. It essentially allows you to conceptualize objects inside of code. So if you've ever taken like CS 111 yet, or like just had any experience with coding, you know how important this really is, and how much like professors are going to test you on it, but not just professors, also interviewers, and like, just your daily coding life is always going to test you on this concept. So the way that it works is it groups different data types together and structures so you can kind of create a unique object. So what I mean by that is, look at this class right here. This car is going to be an object which has different attributes like fuel and max speed, but it also has methods such as like refuel, get fuel, set speed, get speed, and drive. So you're able to do like random stuff with a car because it's an object. It's something that you can actually use. It's not just lines of code. It's something that you constructed and you are able to conceptualize. So this is kind of a way for you to like create concepts that are in the human world and convert it into like the boot beat computer world. Does that really make sense? So really quick, before we get into actually creating a class, object-oriented programming can't really happen unless you go over relative importing. So I'm going to go over that really, really quick. So I have this functions.py script, which, we created this before. It has a bunch of functions which you can import from. So I'm in my main.py, and I want to use the code from functions.py inside main.py. So what I can do is I can import functions. So, all I got to do is type in import functions. So now I could use any of these functions. So if I wanted to use add numbers, I could easily do that. Add numbers 4 and 5. But the reason that this is giving me an error is because there's no such thing as add numbers. There's something called functions.addNumbers though. And the reason why is because when you import this, functions is now an object inside of Python. So in order to access different attributes from an object, use a dot operator. So functions.addNumbers. If you don't want to constantly type functions, what you can do is you could just type import functions as f. So instead of using functions, you just type in f. So again, this is just nomenclature for that, that variable. But if I was even more lazy and I didn't want to type f dot, I could just do from functions import add numbers. So now from functions, I'm importing just this function. So now instead of f dot, I could just run add numbers. Now if I wanted to do all of them, so if I wanted to do both of these functions, I would instead just use star, which is import all. Or I can do add numbers, comma, multiply numbers, whichever you prefer. The good thing about Python is it really is like lenient towards like whatever you prefer. So I just showed you like 6 different ways of importing a function, but to each their own. So yeah, we're going to be doing object-oriented programming now. So let's create a class. So really quick, I just want to hear from you guys real quick. Drop a random object in the chat. It could be inanimate or not. It could be an animal. It could be whatever you want. I just need ideas because I'm not very inspired right now. So really quick, just type in the chat anything that you want to see be made in code. Hospital, dog, cat. All right, I'm gonna go with hospital. I'm gonna go with hospital. I think that has the like the most types of attributes that you can have. So I don't know, like what is there about a dog besides like breed and like how fast it could go? Anyway, yeah, let's make a hospital. So the way to create an object is to first have a class that it is designed for. So we're gonna type in class and then the name of this object, which is going to be hospital. So 2 things that you need to know with classes is you have to define, well, you don't have to define one of them, but it's really good to. So you have to define 2 methods, underscore init and underscore str. All right. So you can notice that I use this word methods, which is something that I haven't ever used yet in this workshop. Essentially, what a method is a function that is no longer in some random Python code, but it is now a part of an object. So anything that is inside of a class is going to be a method. So, all right, let's define the init method, as well as really quick, so I don't forget, the string method. All right, so if you're wondering, this keyword pass, it just allows me to like put kind of like a placeholder in my code so that it doesn't throw errors. Like if I were to remove this right now, it would like throw errors because, yeah, like invalid syntax. So that's why I use pass. All right, so Kyle, I guess since you're the one that that suggested a hospital, can you give me some like random characteristics about a hospital? I can give you one, so like capacity size or something, but Kyle, or really anyone, if you can just give me like a couple attributes about hospitals that kind of make it unique. Logo shape, COVID wing. Okay, so yeah, logo shape. Lights on or off. Okay, so on, off, lights. I mean, I hope that the lights will be on, but okay. And location, yeah. Okay, that's a good start. So these are some different attributes that make a hospital like unique. So for example, like Jersey Shore Medical could have like a capacity size of like 10,000, but like Meridian can have like 500. So like both of them are going to be hospital objects, but the reason that they're unique is because they have different attributes or different characteristics that make them unique. And that's the reason why objects are so important, is because you're allowed to create unique objects. So, all right, let's have these defined. So one other thing that you have to remember about methods, which remember are functions inside of classes, is that you have to pass in one more argument at the very beginning, and it is the self argument. This self argument just means that you are passing it that same object. So that probably didn't make sense when it came out of my mouth, but you're going to see in just a second that if I wanted to define the capacity size, if I wanted to define the capacity size for this particular object, I would do self.capacity size is equal to capacity size. So this seems pretty random. Like, why are they both equal to like each other? But this self.capacity size is referring to like this object's attribute, whereas this capacity size right here is referring to this one, which is a parameter, which is referring to what the user is giving it, like what the user is giving it, like what the user is giving it when you're creating the object. Okay, so I'm just gonna do this for all the other ones. So self.logo shape is equal to logo shape. Self.on/off lights is equal to on/off lights, and self.location is equal to location. All right, so really quick, I'm going to save that and I'm going to test it out. So, okay. So I'm going to go to this one right here. So if you remember, in order to use these different attributes that this script has, I have to import it. So I'm going to import hospital. So from classes_demo, import hospital. Okay, so now I can say like Meridian hospital is equal to, now the way that I create an actual object is by running this right here. This is called a constructor. This __init __ is, oh gosh, is what you call a constructor. So in the Pythonic world, this is an initializer, but in object-oriented programming world, this is a constructor. So how do you call a constructor? You call it the same way that you do with most other programming languages, is not by calling __init, but by calling the class name. So hospital, and then open and close parentheses. So inside of here, you can see that VS Code is actually recommending it to me, which is why I love this thing, is it's telling me what do I need to give it. Well, first I need to give it the capacity size. So, all right, 5,000. Logo shape, say it's a U, I don't know. On/off lights, let's just say this is a Boolean. So a Boolean is a true or false value. So I'm gonna say that this has lights on, because that would be, you know, safety hazard. Location, I have no idea where Meridian, let's just say like Newark, I don't know. But yeah, so now we have an object, and we can access some stuff inside of this object. So if I wanted to access how many people are allowed to be inside of it, or the capacity, I would just do Meridian Hospital dot capacity size. Dot capacity size. So I could print this and run it. There you go. It would give me 5,000. So I can create another one. So let's just say like Jersey Shore Medical Hospital is equal to another hospital. Capacity size, let's say it has like 1,000. Logo shape, a J. Also true, and this one is Jersey Shore. All right, so that SpongeBob episode where he ended up in Newark. You mean rock bottom? Anyway, so with this object, you can then print JSM dot logo size or logo shape. I mean, so this one is printing Meridian Hospital capacity size, and this one is printing Jersey Shore Medical's logo shape. So that's cool and all, but I don't really see a lot of like dynamicness that I've been talking about. So let's kind of create a little bit more of that. So this string function, I haven't really talked about it, but this string function returns something that you declare to have whenever you want to print an object. So really quick, I'm just gonna, let's just return like, I have capacity size, logo shape, and location. All right. So if I hit save, you will see that VS Code is telling me that there's errors. It says undefined variable capacity size. Well, that doesn't really make sense. I mean, this hospital has capacity size, logo shape, and location. So can anybody tell me in the chat why this is wrong? I'll give you guys a couple of seconds to think if you need it. Nobody knows. All right, that's all right. I mean, it's kind of hard to pinpoint exactly why, but the reason is that capacity size is actually not defined. And someone said it's missing the name of the hospital. Well, I mean, that's not necessarily it. I don't even think that we gave it a name, but actually, I think I know where you're coming from. It's close. But the reason why this isn't defined is because capacity size by itself is not defined. In order for it to be defined, it has to be a part of self. So if you remember, we passed in this self keyword. So I have to use self.capacity size because this capacity size belongs to an object. It belongs to itself. So I'm going to type in self. And if I hit save, now there's no errors. So I can go over to run.py and I could print out Meridian Hospital. And if I print out this object, it's actually going to run the string function and it's going to print out, I have capacity size 5,000, U, Newark. There you go. And these are exactly the attributes for this particular object. So with this in mind, I can do a little bit more. I mean, I've only defined 2 functions. Let's say that I wanted to, add some people. So let's just change this around a bit. I'm gonna add in another attribute that says current capacity. Okay. So self.current capacity is equal to current capacity. Okay. It's gonna erase what we have so far. So let's just say that I wanted to have a function that added people to the hospital, right? So def add people. So remember, you have to pass in self. And then you want to also pass in how many people do you want to admit into this hospital, okay? So num admitted. Okay. So what we want to do here is we want to add current capacity, okay? But really quick, if anyone's paying attention, you might be able to catch this. What else do I have to check for inside of add people? So remember, I have current capacity and I have capacity size. Does anybody know what else I have to check for when I'm adding current capacity? Any guesses? Okay, that's fine. So we can add the current capacity by num admitted, but one thing we have to make sure of is you don't want to increase current capacity to the point where current capacity exceeds your capacity size. Otherwise, that's like illegal or something, I guess. So what we're going to do is, first we're going to check if current capacity plus num admitted is greater than or equal to capacity size, then you're going to print can't add more people, too many already, else print successfully added people. So I can just do self dot current capacity plus equals num admitted. So really quick, I know that I threw some errors in here. Current capacity, again, I just wanted to make this error so I could pinpoint exactly how this is important. You have to add self dot when you're modifying a object's current attribute. Okay, so self dot current capacity plus num admitted greater than or equal to self dot capacity size. So again, these are really important because these are pertaining to an object's current capacity and an object's capacity size. So let's see. I'm going to create now like beta hospital number 1 is equal to the hospital, and I'm going to give it a capacity size. So let's give it 1,000. Current capacity, which is 0, J, true, Newark. And so now I'm going to add some people. So in order to run this method, I use the dot operator, like I said before, and dot add people, and inside of it, I have to give a number that I have to admit. So the current capacity is 1,000. So let's just really quick check it works by saying 1,001, and let's run and see what happens. So really, it says you can't add more people because there's already too much, which makes sense because we're adding 1,001, but it can only hold 1,000. So our method works. All right. So now if we do, instead of 1,001, we could do 10. We could print and successfully added people. So if I were to print beta hospital 1 dot current capacity, oops, what did I do? I see that my current capacity is 10 because I just added it. So this is really, really powerful because you can do things to an object and it'll persist throughout your program. I just added 10 people here, and then a line later, it still persisted. It's kind of like setting a variable equal to something, but instead of a variable, it's an object's different characteristics. It's an object's attributes. So with this in mind, you can create as many things as you want. I'm gonna minimize this a little bit. You can create as many things as you want. You could have add people, you can have like discharge people, which subtracts the number of people that's inside of your hospital. You could change the logo shape. All of these different things that you could do are based upon these fundamentals of object-oriented programming that I just showed you. So you could really do so much more than just this with just a little bit more work and a little bit more thinking involved. And with that in mind, I'm going to show you really quick a project that I coded up in like a few minutes using the fundamentals that we just went over in part 1 as well as part 2. These were concepts that are not new to us. Like we have already discussed them. We've already went over all of the different things that you can do with them. So these fundamentals allow you to create something that I made, which is Hangman. So let's see, classes, apply, and Hangman. All right, so really quick, I'm just gonna run this and show you exactly what it does. So what the heck? Okay, Python hangman.py. So really quick, it prompts me. It says, what is my name? I mean, that looks pretty familiar. That's our input function, which prompted us and told us what we needed to type in. So I'm just going to type in my name. And now it says, welcome to that game is starting. Take a guess. So I made my program tell me what the word was because I don't want to look like a fool in my own workshop. So I am just going to do exactly that. Just guess. And it says, okay, I now have 1 win. Do I want to play again? Yes, this game is awesome. So I'm going to do that. So now I have 2 wins. So how is it counting the number of wins that I have? So if I play again and I completely lose, it tells me I have 1 loss, and then, oh, wait, what was the word? Okay. And now I have 2 losses. So how is it able to know and keep track of how many losses and wins that I have? Well, inside my code, I have 2 classes. I have a game board, which allows me to manipulate the game and keep charge of like how many guesses you have or checks to see if your guess was correct. But I also have a player class, which all it does is it has a wins attribute and a losses attribute. And if you win, it just increments it by 1. If you lose, it increments it by 1. And that's all it really does. And that's how I'm able to create a persistent and consistent attribute. And same thing with the game board. I mean, this looks like a lot of code at like first glance, but like really, what does it do? All it does is it generates a random word. It draws the lines so that I could actually play. So those lines were like these lines right here. That's what that function does. And it also checks your guess. So it makes sure that like if you got it wrong, then you know you lose your you lose your guess, I guess. And if you got it right, then it fills in the letter, blah blah blah. And it also has like a print function or a string function. So like really, these are all concepts that we already know. These are concepts that we've gone over, and we're able to create this like pretty cool, like quick little script. I mean, this is just the start of creating a way bigger application. So I'm going to end on that note. Thank you guys for coming. If you guys wanted to maybe do a code along workshop, me and Shriven have both been talking about maybe doing a code along workshop where we go over creating these different ones. So for me, I'm going to be going over the Hangman one. Shriven has his own ideas. So if you guys are interested in that, stay tuned. Make sure to follow Bits on Instagram at Rutgers_Bits. If you guys want to get in touch with me, my email is right on the screen. So yeah, thank you all for coming. If you guys have any questions, please just drop it in the chat. I will try to answer to the best of my ability. But otherwise, thanks again. Stay safe, everyone. And yeah. Yeah, so the recording is going to be posted as soon as this meeting ends. I'm going to upload it, and we're going to be able to distribute it. So as of right now, it's kind of annoying to have to like distribute it to each individual person. Part 1 is already available, so all you got to do is contact the Bits email. So if you don't have the Bits email, I could drop it. Shriven can probably drop it in the chat if you don't already have it. So just contact them. They'll be able to give you part 1. And as soon as this is done uploading, I'll give you part 2. But in like a few weeks, I'll have the website up and running. So you could basically watch any workshop that you want straight from the website. But yeah, for now, just email the Bits email and let them know that you want them. So yeah. Yeah, I don't know the email at the top of my head. So Shriven can drop that if need be.